Hello everyone, welcome back. Today we will discuss a little about triangles. There are so many different types of triangles, but the right triangle or right angle triangle is the most important triangle that we study a lot in trigonometry, in geometry, all over. Now, thing is, what makes a right triangle such an important triangle? And the answer is simple, because it is everywhere. For example, in this picture, this boy is looking at these different world famous buildings. So whenever this boy looks at any of these buildings, have a look at the triangle that is made. For example, Statue of Liberty, if he looks at a Statue of Liberty, the triangle formed is a right triangle. From US to Cappadocia in Turkey, you look at these hot air balloons, the triangle made is a right triangle. Big Bang, the angle made is a right triangle. Going to Kremlin, angle made is a right triangle. Going to Taj Mahal, angle made is a right triangle. So right triangles are everywhere. See, all man-made buildings except Leaning Tower of Pisa, all man-made buildings and natural structures are always vertical. When they're vertical, and if you look at the top of any building, then the triangle made is always a right triangle. That makes a right triangle one of the most important triangles in the study of trigonometry. So today we'll try to go beyond a triangle and see how do we solve simple real life problems with the help of trigonometry. Now, before we move on to that, I would like you all to review a few things, recall a few things. If you have a triangle, a right triangle, and if one angle is given, let's say this angle is given, then the side opposite to this angle, given angle, is always called opposite. The slant side is always hypotenuse and the other side is always adjacent. If this angle moves from this point to another point, for example, this is another triangle ABC. If here is your angle, then which will be the side opposite to this? Side BC. So side BC will become opposite side in this case. The hypotenuse will remain same. The adjacent will be now side AB. Also recall Pythagoras theorem, which says that hypotenuse squared is opposite squared plus adjacent squared. I see often that students learn it as c squared is equal to a square plus b square. Avoid that. Learn it as hypotenuse squared is opposite squared plus adjacent squared. And also recall, in a triangle, trigonometric ratios are always constant. And these are sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. And a popular way to memorize this is SOHCAHTOA. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now, another concept. Now, whenever we look at any object, our eyesight and the horizontal line, they always make some angle. And these angles are frequently studied in mathematics. So what are these angles? Have a quick look. For example, you see these two gentlemen and they're looking at each other. Now, when they look at each other, there is an angle made with the horizontal line and the line of sight. Similarly, from top, if you look downward, there is an angle that is made. So when you look upward, the angle made with your eyesight and the horizontal line is called angle of elevation. In this case, this will be your angle of elevation. If you're looking down, then the angle made with the line of sight and the horizontal line is called angle of depression. Angle of elevation and angle of depression are always equal. Let's explore this further with the help of an example. Here is an example. Sam, during his visit to Jakarta, observes that the angle of elevation to the top of the national monument, that is Monas, is 30 degrees. After walking 100 meters towards the monument, the angle of elevation increases to 45 degrees. First part of the question is illustrate the situation with the help of a diagram, and second is calculate the height of monas to the nearest whole number. So if you see, Sam is standing at some point on the ground, which is, the distance is not given. The only thing given is the angle of elevation is 30 degrees. So here is your beautiful monas. Let's say this is the position of Sam. So when Sam looks at the top of the monas, the angle of elevation is 30 degrees. So this angle is going to be 30 degrees. So again, a right triangle, and this angle of elevation means looking up. So this will be the angle of elevation, and this is 30 degrees. Now Sam moves towards monas. So Sam has to move towards monas. So Sam moves there by 100 meters. So after walking 100 meters, the new angle of elevation is 45 degree. So this angle is going to be 45 degree. Now, when you bring it to maths class, we can find all unknown measurements and we can work with the basic knowledge of trigonometry. So second part is calculate the height of monas to the nearest whole number. Here is your diagram. So 100 meter, 30, 45, and we have to find this height. So first thing we can do is let's label this diagram. So this is A, B, C, and D. We have to find height. So let's assume that height is H. So we have two triangles here. So if you work in triangle BCD, in triangle BCD, H upon BC is opposite over adjacent, and opposite over adjacent is tangent. So H upon BC will be tangent of this angle of elevation, that is tan 45 degree, which is 1. So H upon BC is 1. So this gives you BC and H are equal. BC is equal to H. So you can label this BC as H now. Now looking into the big triangle, that is ACD. So in triangle ACD, what do we get? H divided by AC will be opposite over adjacent. So that is again tangent. So you get H over 100 plus H is equal to tan 30, which is 1 over square root of 3. By cross multiplication, you get a square root of 3 times H is equal to 100 plus H times 1 is 100 plus H. Take H to the left hand side. Square root of H minus H is equal to 100. Take H common. You get root 3 minus 1 is equal to 100. So H is equal to 100 over square root of 3 minus 1. Remember, the question was find the height of monas correct to the nearest whole number. So when you find this using your calculator, the nearest whole number is approximately 137 meters. The actual height of monas is 132. Out here for this question, it is coming 137 meters. So this is how we can use basic trigonometric ratios, angle of elevation and angle of depression to solve some real life problems. If you found this video useful, please like it, subscribe it and share. And don't forget to press bell icon so that you are the first person to get the notification. You can also reach me at Jalaj Maths on Instagram. Till we meet again, take good care. Bye-bye.